Alright, in this video here we're going to be looking at assignment number 40, and we're going to be looking at kind of a brief introduction to graphing exponentials. So an exponential function will be, very basically it will be the form f of x is equal to b to the x power. B is going to be your base, where the base is greater than 0 and the base is not 1. If your base is greater than 1, we have what's called exponential growth. And if the base is between 0 and 1, then we have what's called exponential decay. The domain for an exponential will always be all real numbers. The range will be depending on if you have any sort of vertical shift, but in stock form, just a b to the x is going to be 0 to infinity. And then in stock form, you have a horizontal asymptote of y is equal to 0. And that'll change if you have any sort of vertical shift. To keep things very simple, we use the 3-point method for graphing an exponential function, b to the x. And so why don't we go ahead and do a sketch of what exponential growth looks like. So there would be an example of exponential growth. So it is going to be increasing as you go from left to right. Exponential decay is going to be the reflection across the y-axis, and so we have exponential decay. And these can be used to model certain types of things that we see in the real world, such as population growth, bacteria growth, also with investing money, how is your money growing, that kind of stuff uses exponential models. And to keep it simple for graphing, we're going to use what's called the 3-point method for graphing an exponential function of base b. So we'll always use these 3 points, -1, 0, and 1. If we use -1, we're going to be using the exponential rule, b to the negative n is equal to 1 over b to the n. So b to the minus, oops, I went too far. B to the minus 1 is going to be 1 over b to the first power, or 1 over the base. B to the 0 is always 1, and b to the first power is just the base. Okay, so let's go ahead and graph an exponential. So we're going to graph f of x equals 2 to the x power. We'll also figure out what the domain is, the range, and the asymptote. So we're going to do the 3-point method, x and 2 to the x power. We're going to use the 3 points, -1, and so we'll have 2 to the minus 1, which is 1 over 2 to the first power, which is just a half, and so we'll go ahead and do our best guesstimate over here. Okay, so -1 and 1/2, and then we'll evaluate our exponential at 0. So 2 to the 0 power is 1, so we'll go ahead and put that in there. And then 2 to the first power is just 2. And so we can put that in there. You can do more points if you want to. 2 squared is 4, and 2 to the third power is 8. Okay. And then let's talk about the horizontal asymptote. So we know that 2 cubed is equal to 8. So 2 to the minus 3 is going to be 1 over 8. And I believe that is a 0.125. So that's actually getting pretty small. If I do 2 to the minus 10, that's going to be 1 over 2 to the 10th power. And let me get my calculator here, and we can see what that is approximately. Okay, and that's going to be 3 zeros, 1, 2, 3, 9, 7, 6, 5, 6, 3, etc. And so that's going to be like super close to the x-axis there. And so we do have a flattening out behavior there. And so our horizontal asymptote is going to be y is equal to 0. Now it's only going to go in one direction. When we were talking about the rational functions, our horizontal asymptote was in both directions. So this is just going to be one direction. Okay, so we'll draw in our horizontal asymptote as a dashed line. And then we'll go ahead and connect our dots, and knowing roughly what the exponential function looks like, nice smooth curve, we'll label it 2 to the x power. The domain of an exponential is always going to be all real numbers, and the range for in stock form is going to be all positive, so 0 to infinity. Okay, so that's your most basic 2 to the x power. Most of the things that we're going to be graphing in this class are probably going to be bases of 2, bases of 3, maybe 4 and 5. I don't think we get too much higher than that. And also the exponential base e, which I think we look at in the next video. All right, so I think we got 2 more examples. So we're going to graph 3 to the x power. Okay, so x is y equals 3 to the x power. We're going to need to use the 3-point method. So I'm going to use -1, so 3 to the -1 would be 1 over 3 to the first power. So we'll go ahead and attempt to graph -1 and 1/3 to the best of our ability. 0 and, when we plug in 0, we have 3 to the 0, which is 1. So 0, 1. We'll plug in 1. 3 to the first power is 3. That is sufficient. If you wanted to do 3 squared, that'll fit also. So 3 to the second power is 9. You don't have to. We're just looking at the 3-point method. But if you want to, you can do a couple extra dots. All right. The horizontal asymptote, there's no vertical shift going on. So horizontal asymptote is going to be y equals 0. And we'll go ahead and graph this. This is also another exponential growth. The domain is going to be all real numbers. And the range is going to be the positive numbers. Okay. All right. And number 3 here, we're going to do our first transformation. We're going to look at f of x is equal to -2 to the x power. The negative is on the outside, so it is not being raised to the x power. When we did define exponentials, the base was greater than 0 and not 1, so that excludes negatives. Okay. So this is going to be a reflection over the x-axis of 2 to the x power. Okay, so our parent graph is 2 to the x power. Recall that we graphed that on the previous slide, and we used the points -1, 0, and 1, so that gave us 1 over the base, 1, and then the base. You can plug in a couple of extra points. I did 2 squared is 4, and 2 cubed is 8, not required. We can also put in a horizontal asymptote, and then connect our dots for the 2 to the x power. Okay, so now we're going to talk about the transformation of reflecting over the x-axis. So we'll start with the horizontal asymptote. That'll kind of help guide things. So because the horizontal asymptote is on the x-axis, when we do the reflection over the x-axis, it stays put. But we can take our 3 points and reflect each one of those over the x-axis. Okay, and we had a couple extra ones, so we can reflect those too. And we'll connect our dots. And so this is -2 and then to the x power. The horizontal asymptote is unaffected here. It's y equals 0. The domain is also unaffected. That is all real numbers. However, the range, I said earlier, the range is affected by vertical shifts. It is also affected by any sort of reflection over the x-axis, and so that is now going to be -infinity to 0 is your range. Remember, the range is low to the high, so the lowest it goes is -infinity, and the highest it gets is positive infinity. Okay, we got a couple more examples on the next video, so we'll see you in a few minutes.